Hello class, how are you? Today I'm going to talk about the continuation of finding an antiderivative using partial fraction decomposition, and I'm hoping in the future video I'll talk about the difference between the antiderivative and the definite integrals, and the difference between these two terminology, and why one called antiderivative, the other one called definite integrals. And therefore, let's leave those for the future videos. Today, I want to take this function, which it is the derivative of some function, and that function is represented by the x. And how I'm going to find is antiderivative. First, I have to discuss, number one, can I apply the chain rules, which is the derivative of a composite function? The chain rules, you have to have derivative of inside available. And most likely when it's a rational function, you want to make sure your bottom represented the inside function and the top outside function, and the derivative of the inside function be on the top, that you can apply logarithm. Therefore, I have to make x squared plus x minus 2 my outside function, and its derivative is 2x plus 1, which the top is really way different from 2x plus 1. Number two, I want to know if this one is tied to any kind of an inverse trig function. At top of my head, I cannot think of anything like that. It's not easy. Then I can think of finding the antiderivative using integration by part. Well, I don't know which one to get u, which one to get v, which one to get dv. Is not easy. Trig substitution is possible, but it's not an easy approach. Therefore, I don't know any other technique unless I be able to find the factor of the bottom. But prior to the factor to the bottom, you have to determine if this one is proper or improper. You cannot apply partial fraction decomposition into an improper rational function. And we talk about improper. If the leading variable on the top, the power is equal or greater than the leading variable on the bottom. Therefore, if A is greater or equal to B, this is called improper. But if A is less than a B, called proper. Well, here A is 3. Sorry, B is 2. And A is way greater than the B, that's improper. Then how do we approach problem when it's an improper rational function? You have to use long division to make this one a proper. Therefore, your x cubed minus x plus 3, this one called your dividend. Your x squared plus x minus 2 is your divisor. I'm looking for the quotient, and I'm hopefully the quotient become a polynomial. Then whatever the remainder is, that remainder over the divisor, I'm hoping that piece become proper. Then I can apply partial fraction decomposition. Then every time you do long division, make sure your polynomial is in a descendant order. This is x cubed. I do not have x squared. I have to add x squared. Then I have a power of 1. Then I have power of 0. Therefore, I'm going to write x cubed plus 0x squared minus x plus 3 divided by, but this is already in a descendant order. Therefore, for long division, you have to be able to know the process of dividing, multiplying, subtracting, and bring it down. This process has to repeat it all the time. This left line is always do the division. The right line is going to do multiplication. This horizontal line is going to do subtraction. Then I'm going to bring it down. Therefore, you have to take your first term divided by the first term, which is x cubed over x squared. That become your x. That x has to be multiplied by your divisor. And if the first term is not equal to the first term of your dividend, you made a mistake. This is x cubed plus x squared plus 2x. Do you see how this 0x squared was important? Because you can line everything up. I did divide, I did multiply, I need to subtract. Positive, it become a negative. A positive become a negative. A positive become a negative. I put them on the circle that make sure to remind me these are your new sign. Then if I made a mistake in the future, I can go back and see what sign we had and what did I change it to. X cubed minus x cubed is 0. 0x squared minus x squared is negative 1x squared. And negative x minus 2x is a negative 3x. I need to bring it down. Therefore, I apply all four of them. I start again. Negative x squared over x become a negative x. Oh, that was x squared. No, x cubed over x squared was a x. Oh, x squared over x squared is a negative 1. I made a mistake. Okay, this one was x cubed over x squared is an x. And this is negative x squared over x squared is negative 1. I multiply negative 1 by x squared plus x plus a 2. That become negative x squared minus x minus a 2. I subtract. Negative times negative make a positive. Negative times negative make a positive. Negative times a negative make a positive. Positive negative x squared positive x squared is 0. Negative 3x plus x is a negative 2x. Plus 3 plus 2 is plus 5. See that power right here is 1. Therefore, there is not any x squared into the x. Therefore, instead of writing x cubed minus x plus 3 over x squared plus x minus 2, I write my x minus 1 plus your remainder over the divisor. Right now, this is a proper one. Maybe I'll be able to apply partial fraction decomposition. I know how to integrate that. That x squared over 2. I know how to integrate that. That's a negative x. Let's see if the bottom can be factored. If I write x plus 2 and x minus a 1, that becomes x squared minus x plus 2x is a x minus 2. Yes, that one can be a factor. That is a linear factor. Therefore, I put a on the top with the x plus 2 in the bottom. In this is a linear factor. I put a b on the top, x minus 1. But this must become equal to x squared plus x minus 2, which is x plus 2x minus 1. Therefore, this denominator and this denominator must be the same in order to compare the numerator. Therefore, when I see this one by itself and this one by itself is not equal to that. Therefore, in order to make it equal to that, I'm missing x minus 1. In here, I'm missing x plus 2. Therefore, do you see this and these are exactly the same? I get a common denominator, which is x plus 2 times x minus 1. But because you multiply this bottom by x minus 1, you have to multiply the top by x minus 1, which is ax minus an a. Because you multiply the bottom by x plus 2, you have to multiply the top by x plus 2. And that becomes bx plus 2. And that's equal to x squared plus x minus 2. And the top is a plus b times x. And this one is a 2b. A plus b, and this one is plus negative a plus 2b. I'm sorry, I'm going to rewrite this one. I had Didn't have enough room right here. Therefore, I'm going to write a plus b times x plus negative a plus 2b. My denominator was x plus 2 times x minus 1, and that's equal, must become equal to negative 2x plus a 5 over x plus 2 x minus a 1, which is because I wrote it as a factor. See, these are the same. Right now I have to make my top equal to each other. Therefore, your a plus b should become equal to a negative 2. Negative a plus 2b should become a 5. That's the system of equation. I do addition and elimination. I'm going to add these two together. A minus a is 0. I have 3b equal to 3, b equal to 1. And if b is 1, a plus 1 is negative 2. I bet you b a is negative 3. Okay, what do I have right here? In here, I had x minus a 1 plus what I had bottom of the a, I had x plus 2. Therefore, my a is negative 3 over x plus 2. And what was b? Your b is 1. The bottom was x minus 1. Right now, I'm going to integrate this instead of that. Do you see how I broke it in part? It's just like factorization. Factorization helps you to find the roots very easily. You don't have, if it can be factored, don't use quadratic formula. Factorization, you can cut them in pieces and find the roots. Therefore, I cut this one in pieces, and I'm going to say, what is the integral antiderivative of this one with respect to x? Is x squared over 2 minus x minus 3 natural log of x plus 2 plus natural log of x minus 1. If you really want to apply some technique or rule of logarithm, remember that's the 3. The 3 can move over here, and I'm going to write x squared over 2 minus x plus natural log of x quantity x minus 1. I'll write my positive first, then I'll write my negative next, which is x plus 2 cubed. And what is, when do you subtract 2 power? When the power is written in form of a division. X minus 1 over x plus 2 cubed, absolute value plus c. This is one of the function that is derivative is this. And that's called the antiderivative. Therefore, I undo the rule of a derivative to find a function that is derivative is this. Another student gonna say, okay, give me another example. That's an example. Yes, these are the factors. But these are in terms of exponential function. Let me, if I can change this one to somehow to an algebraic function, because it's easy for me to solve algebraic, and I can do partial fraction decomposition if it's in terms of algebra other than this one. Therefore, if I make e to the power of x become u, your du is e to the power of x dx, which you do have e to the power of x dx on the top. Therefore, this is your du. Therefore, I make some kind of a transformation. Instead of using x to represent my function, I'm going to use u to represent my function. Therefore, when I transform it to a u, my function is going to be changed. It's going to be written in a different format. E to the power of 2x is the same as e to the power of x squared, and this is nothing except u squared. Therefore, in here, that becomes 1 du over u squared plus a 1 and u plus a 1. That's very easy. And I hope you know the power of the bottom is 3. The power of the top is 0. That's proper. Proper, I already know the factor. A quadratic, a linear. Quadratic need ax plus b, not x, because I transform it to a u. a u plus a b over u squared plus a 1. And the other one is b. Not b, I have already used a and a b. I'm going to use c, u plus a 1. Somebody said, could I have used b? That b might be different from that b, and then these two b are look the same. Therefore, I'm going to write with the different letters that it can show me the different quantities and doesn't get me confused. This has to become equal to u squared plus 1, u plus 1. You got to make this denominator just like this. This just like that. How can I make this one just like that? I have to multiply by u plus 1. What you did to the bottom, you got to do it to the top. How can I make this one just like that? I need a u squared plus 1. I multiply this one by u squared plus 1. And the top is 1. Oh, okay. If I'm missing something, I'm going to add it in the future. This become a u squared plus AU plus BU plus B, I use FOIL, plus CU squared plus C all over U squared plus 1 times quantity U plus 1 equal to. The highest power is 2. I don't have it. I put 0 U squared. The next highest is 1. I put 0 u power of 1. The next is a constant. I do have the constant. And the bottom is u squared plus 1, u plus 1. These are the same. The top has to be the same. The coefficient of u squared is a plus c and must be 0. The coefficient of u is a plus b and must be 0. The constant is b plus c and must be 1. Therefore, I know if I take these two and eliminate a from it, I ended up with c and a b, and I used that sum with that b and a c with that equation to solve for b and a c. I multiplied the top by negative. You have negative a minus a c equal to 0, a plus a b equal to a 0. Therefore, b minus a c equal to 0. B must become equal to c. Excuse me. If your b is c, therefore the 2c have to be 1. C is 1/2. Okay, I got one of it. If c is 1/2, your b is 1/2. Do you see when I talk about these two that make sure do not make them same b, because right now your b and c are the same. And you could make this one a b because they were the same, but what happened if they were different? And this one, a plus b is 0. A is a negative b, therefore your a is negative 1/2. Okay, I got all three of them. What was your a? A is a coefficient of u. Negative 1/2 u. Your b is a constant over u squared plus a 1. Plus your c is a 1/2 u plus 1. I see 1/2 as a common factor in here. I factor negative 1/2. I see u minus a 1 over u squared plus a 1 du plus 1/2 1 over u plus 1 du. Let me take care of this and say, okay, I know what this one is. This is my inside function. I'm going to call it a v, and derivative of differential of a v is du. Therefore, you're going to have dv over a v. The integral of dv over a v is a natural log of v. Therefore, this one is 1/2 natural log of the v, which is u plus 1. But when I look at this, I said, I wish I didn't have that negative 1. If I didn't have that negative 1, I could use this one, u substitution. Okay, just ignore it, please. And say, I'm going to write negative 1/2 bracket integral of a u over u squared plus a 1 du But what do you do with the negative one? You can decompose this and say negative 1 over 1 over u squared plus 1 du. If this one become your v is u squared plus 1, your dv is 2u du. I don't have a 2, I put a 2 right here, and I multiply the bottom by 2. I have negative 1/4 of dv over v. And what function the derivative is? 1 over the u times du is the natural log of the u. But somebody said, what is this? This is nothing except a squared plus b squared. And a squared plus b squared is nothing except tangent, deal with opposite over adjacent. This is the length of the hypotenuse, because if this one become u and this become 1, this is nothing except u squared plus 1. Therefore, this is arc tangent, and it is a unit circle. You put negative 1 arc tangent of u plus 1/2 natural log of u plus 1. Don't forget that negative 1/2 belongs to both of these. Therefore, the first one become a 1/4, a negative times a negative make it a positive 1/2. I need it here. Therefore, if you want to look at these two, you can combine these two. Move the 1/4 in here, move the 1/2 in here, put natural log of a square root of u plus 1, because that's making it a square root. On the bottom, that becomes power of 4th. That's the 4th power of u squared plus 1. Negative, it comes on the bottom, plus 1/2 arc tangent of u plus c. Okay, I have an issue. I gave you my function in terms of x, but you cannot give it to me in terms of u. What was u? U was e to the power of x. Then tell me what was the answer to e to the power of x over e to the power of 2x plus 1. That quantity times quantity x plus 1 dx is the natural log of a square root of e to the power of x plus 1 over the 4th root of e to the power of 2x plus 1, because e to the power of x squared is e to the power of 2x, plus 1/2 arc tangent of the e to the power of x plus a c. You gotta have patience. You cannot just solve mathematical problem without enjoying doing it. Therefore, you have to talk to yourself while you're solving the problem. The student gonna say, any more example? Is right here. I know the bottom can be factored. The factor of the bottom is cosine times 1 plus cosine of x. It's two linear factors. But they are not from same fabric. Therefore, if I want to compare the top, this coefficient is going to be in terms, this factor is going to be in terms of cosine. Therefore, the top has to be in terms of cosine. Let me see if I can change this one to an algebraic rational function. I'm going to say my cosine of x equal to v. I don't want to use u all the time. My dv is negative sine. What is the derivative of a cosine? Negative sine. I don't have a negative here, but I do have sine x dx. I put a negative here and a negative here. Therefore, I'm going to transform mine to 1 dv over v plus v squared. And I write this one as a negative 1 over v times 1 plus a v dv. This is called a proper. And the factors are v, and the factors are 1 plus a v. And these have to become equal to v times 1 plus a v over 1. How can I make this look like this? Multiply by 1 plus a v. How do I make this look like this? Multiply by a v. The bottom are the same. The top has to be the same. A plus AV plus BV equal to 0V plus 1. Factor the V. I have A plus B. Remember, these are constant multiples. I put my constant to the left. Plus A equal to 0V plus 1. That's very easy. A plus B equal to 0, and A is 1. If A is 1, B is negative 1. That was so simple. My A over V become 1 over V. My B over 1 plus V become negative 1 over 1 plus V, because B was negative 1. And I'm going to integrate this one respect to the V. This is the natural log of V minus the natural log of 1 plus a V plus a C. I can write this one as a natural log of V over 1 plus a V plus a C. What was my V? My V was the cosine X. That problem was not hard. Do you see the transformation? Transformation sometimes help you to reach your goal much quicker than you are anticipating. Therefore, this is the end of the examples for partial fraction decomposition. The next technique that I'm going to discuss is a technique that what happens if I want to find definite integrals and I cannot use chain rules. I cannot use inverse trig function. I cannot do it by integration by part. I cannot do trig substitution. I cannot do partial fraction decomposition. If I don't, these only few techniques that I study in calculus 1 and 2, if I cannot use those techniques, would you give me a technique that I can find? I said find indefinite integrals. Not antiderivative, indefinite integrals for any function that you cannot find is antiderivative. And I'm going to discuss that one. And that's called a numerical method.